Right. Good morning, everybody. I hope everybody's having a fine and pleasant day. Here we go, January 6th. And yesterday we talked about the conservation of energy in terms of the skate park physics FET that I had you do. Hopefully, you spent some time working with this FET and turned it in. It'll help you understand conceptually, meaning explain what happens to energy. We're using words. Uh, when we're in a situation like this right here, we take a skater and we can see that when we lift the skater above the ground, the higher we lift the skater, the more potential energy it has. Okay. The lower the skater goes, the less potential energy it has. Now, because potential energy is mgh, the mass stays the same, but and g stays the same. But as I change h, I'm going to see a corresponding change in gravitational potential energy. Once again, going higher gives you more potential energy. Going lower gives you less potential energy. If I take the skateboarder and put them onto this frictionless half pipe here, we can see that when I let them go, they will go in vibrational motion up and down the sides right there, and we're going to see that there's going to be corresponding changes in the energy. Remember that when we lose height going downhill, we're going to lose potential energy. When we go up the hill and gain height, I'm going to gain gravitational potential energy. Okay, but where does that energy go? According to the conservation of energy, energy is never created or destroyed. It's just transferred from one form to the other, as long as we neglect friction. We should understand that friction will cause the object to slow down, but we've neglected it here. So there's going to be a perfect energy um, conservation in this situation. So what does that mean? It means that I start with potential, and when I go down the hill, whatever potential I lose, I'm going to, because I'm losing height, I'm going to start to go faster and faster and faster, which means that I'm going to get the other form of energy, which is called kinetic energy. Kinetic energy is gained when the object increases its velocity. When it goes down the hill, we're going to lose the potential that it has, and that will be transferred into kinetic. At the bottom of the hill, we're going to see that we're at our maximum with kinetic. If we, I'll stop it, pause it. If we look at the top of the hill right here, we're going to see that our potential energy, all of our energy, which is the total energy, is potential energy. But as I start to step down, we're going to see that I will lose my potential energy because I'm losing height and gain kinetic energy because I'm gaining speed until I get all the way to the bottom where all the potential energy I had at the top is converted into kinetic. As I start to go up the ramp, we're going to see that it will start to gain the height back, which means gain potential back, but lose velocity. Think about it. If it goes uphill, it's going to slow down as it goes uphill. Eventually, it will get up to the top and it will stop there. And we can see that I have zero kinetic energy, and my energy is all back in the form of potential. The total sum of kinetic, meaning atom together, and potential are going to be what's called the total energy. The total energy in the system will remain constant throughout the entire trip, as long as we neglect friction. All right, I'm going to go over to Smart Notebook, and we're going to start to talk about the lesson now. Okay, now I'm back in the Smart Notebook. We saw that when the skateboarder went down the ramp, he lost potential and gained kinetic, and vice versa. That's going to be what's called the conservation of energy. The energy that I start with at the top of the hill is going to be equal to the energy at the bottom of the hill. It's just going to change forms. It starts with potential and then goes into kinetic. At the bottom of the hill, it has all kinetic. It's going to go back up to the top. It's going to lose that kinetic, which is transformed into potential energy. So I know that that may sound confusing, but it's not that bad. If we were to look at this situation right here, this is just a picture As this goes down the hill, it starts with all potential energy. Whenever it loses potential energy, it's going to stack into kinetic energy. So let's go ahead and let's try some basic word problems with this conservation of energy situation here. In the first problem, we're going to say that a 35 kilogram mass is dropped from a height of 17 meters. What speed will it be when it hits the ground? So it's important to acknowledge that when we start with the mass right here, oops, let me start. When we start with the mass right there at the top, because it has height, it's going to have GPE. So it's going to start with all GPE at the top, and it's going to be transferred into kinetic energy at the bottom. So how do we work this out mathematically? We just set those equal to each other. Because the GPE at the top equals the kinetic energy at the bottom, we're going to be able to go ahead and say that GPE at the top is equal to kinetic energy at the bottom. Let's go ahead and write our formulas. Kinetic energy at the top, I'm sorry, GPE at the top is mgh at the top will be equal to 1/2, I'm just going to do 0.5, mv squared at the bottom. So what I'm showing is that the GPE at the top is equal to the kinetic energy at the bottom. Let's go ahead and plug stuff in, the masses. So we're going to be able to try and solve it for v, because we're looking at the velocity at the bottom. We know mgh, so we can just find v. Let's go ahead and do this now. So the mass we know is 35 times 9.8 times the height, which is 17. That's equal to 0.5 times 35 times v squared. Now I'm going to be looking for v. It's being squared. So I'm going to have to take the square root when I'm done. Let me do the math. 35 times 9.8 times 17 is going to be 5,831 will be equal to 0.5 times 35, which is on the right side of the equation, is about 17.5 times v squared. Now, I'm looking for v squared, and we really haven't done that much of this. Okay, the first step in order to get to v squared is to divide both sides by 17.5. Let me do that math on my calculator. The answer I get is v squared, which is on the right side, I'm just going to flip it, is equal to 333.2. I have to take the square root of that. So if I hit the square root button, we're going to see that the velocity will be equal to about 18 meters per second. Why did I have to? That's the answer. I'm sorry, it's squished. Why did I have to take the square root? And that's because in this equation, v is squared. V is still squared here. So v squared equals 333.2. I just have to take the square root to get the v. All right, let's go ahead and go to the next problem right here. I'll have more room to work with right here. It's the same type of problem. We start with a 4 kilogram mass. It's being dropped from a height of 9 meters. What will the speed be as it hits the ground? Okay, so the way we do this is we know that when it starts at the top before it's dropped, it starts with all GPE. And then when it gets down to the bottom and hits the ground, it's lost all of its height. Its height is turned into velocity. So we're going to see that that's going to be equal to the kinetic energy. Let's go ahead and write the formulas. GPE is equal to mgh. KE is equal to 0.5 mv squared. So let's start plugging in. 4 times 9.8 times the height, which is 9, is equal to 0.5 times the mass, which is 4, times v squared. So let me do my math on the left side. 4 times 9.8 times 9 is equal to 352.8. Will equal half of 4, which is 2 times v squared. If I divide by 2 here and divide by 2 here, I get v squared alone. I divide by 2 on my calculator. So I want to end up with I'm gonna start working up here. V squared. I'm sorry. Let me just do the little old arrow. V squared is equal to 352.8 divided by 2, which is equal to 176.4. 176.4, if I take the square root, remember I don't want V. I don't want V squared, I want V. It's equal to about, V is equal to about 13.3 meters per second. Good. All right, so let's go ahead. I'm going to leave this number 3 problem for you, which is going to be the lowest lane. Superman drops the lowest lane. You're going to find her speed. That's going to be one of your assignments for today. Okay, and that leads us to the other type of problem here. I only have about 4 minutes left in my recording, so I'm going to have to move on. And that's going to be that we're going to start with an arrow that's shot upward, and we're going to see that the arrow is shot upward with a velocity. It's going to go up to a height, and we want to find out what that height is. Okay, so now I'm going to do the opposite direction. I'm going to start at the bottom of the hill, where I have all Ka, and I'm going to go to the top of the hill. Okay, so how do I do that? I start with Ke at the bottom, and it's going to be converted into GPE at the top. So I set them equal to each other. I acknowledge that these are hard problems. So let's go ahead and write in our formula here. Kinetic energy is equal to mv 0.5 mv squared. And this is equal to mgh. Now, I'm going to be looking for h. I'm going to be looking at the maximum height that it goes to. That's my unknown variable. Let me plug in everything that I do know. 0.5 times the mass, which is 0.25, times the speed squared, 17 squared, will be equal to the mass, which is 0.25, times g, which is 9.8, times h. So now I'm going to have to solve it for h. I need to do this times this times this equals this times h. So let's do the math. 0.5 times 0.25 times 17 squared is equal to 36 here. I'm just going to do whole number. On the right side, 0.25 times 9.8 is equal to about 2.5 times h. So therefore, so now look, I'm left with 36 is equal to 2.5 times h. H will, if I divide by 2.5 on both sides, 36 over 2.5 equals 14.4. All right, real fast, and that's going to be meters. That's the height. I have less than a couple minutes left in my recording. I want to do one more example problem for you really fast right here, and we're going to shoot a clown upward out of a cannon, and he's going to lose velocity and gain height. So we want to know the maximum height that he reaches. He starts with all kinetic energy as he's launched from the tube. And it's equal to the potential energy that he will gain when he loses velocity and gains that. I have a minute and a half left. Let me hurry. 0.5 mv squared equals mgh. I know it's a little bit chicken scratch. Let's plug the stuff in. 0.5 times, whoops, 0.5 times 120 times the speed squared, 7 squared, equals 120, which is the mass, times g, which is 9.8, times h. So I have to do 0.5 times 120 times 7 squared. 0.5 times 120 times 7 squared is equal to 2940 on the left side. 120 times 9.8 is equal to 1176 times h on this side. So h will equal 2940 divided by 117.6. The height is equal to 2.5 meters. Now I know this algebra is a little bit challenging. You're going to be all right. I'm almost out of time here. So what we'll do is I'm going to ask you to do problems numbers